Hello everyone, welcome to another pre-algebra with Professor V. So today what they wanted us to look at is the subtraction property, okay? So-called subtraction property. So anyway, let me go ahead and so we will do some order of operations. But I had this epiphany through teaching that, there's really a way to solve any equation, they try teaching this one step or two step problems, but the reality is, you know, you don't need all that. You just need to know two things, okay? So here's PEMDAS, right? Order of operations. We go down. But this is not mostly, this is for expressions, okay? Now, when we're doing equations, well, guess what? We want to go the opposite way. But we also want to do the opposite, okay? Opposite. So, what I mean here, right? So let's go into it. So we have this expression, right? C plus 8. Now, if you watch the like term video, right, we cannot add C plus 8, right? So these aren't like terms. Now it equals 14. Now this is an expression here in itself, right? 14. It's doesn't have much going on with it, but so we go top down, we're trying to solve for some expression and we can't, right? So we start going back up. Subtraction and addition become first, right? So this C plus 8, right? Let me go ahead and start writing it out. The only thing we could start doing is undoing the math, right? To solve for C, right, it's almost like we have a box plus 8 equals 14, right? But this one in particular isn't very hard, right? What is this? 6? Right? 6 plus 8, 9, 10, 11, 12, 13, 14, right? So 6 would definitely satisfy this. But, we don't always end up adding such small numbers, right? So the way to truly do this is to minus 8, right? If we can isolate the variable, then we can get some sort of value, right? So 8, positive 8 minus 8 is C. So that's exactly what we want, right? We want to know this box. We've given it a variable, but we don't know what it is. Now, for this to work, there has to be balance, right? We can't just minus 8 from the left side of an equation. Otherwise, it's not equal, right? Equation equals, right? So you do have to minus 8 from this side. The equal stays in the middle. And we do end up with 6, right? And you can always plug it back in, right? And figure out if you did it right. So 6 plus 8 equals 14. Well, 14, oops, equals 14, right? So we are good here, right? We could always check if we did things right. But anyways, I'm going to erase this so I have more room. So now we have e plus 8, right? Equals 150. So if I go down PEMDAS, right? If I go down the order of operations, I see an add. But they're not like terms. So I start saying, okay, well, there's only a number on this side. This has a plus, right? No like terms. I must be undoing. I must do the opposite. I must go down, right? So I minus 8 from both sides. So on this side, we end up with just v equals, right? Because what's v plus 0? Well, v, right? And here we have equals 150 minus 8, so that's just 142. If you need to borrow and do all that good stuff, you may, right? Now we could substitute the 142 back in, right? Once we have this value, we can evaluate, right? So 142 plus 8 equals 150. Well, 142 plus 8 is 150, so 150 equals 150. We have solved for this variable. All right, now on this one, right, they have a 23 on this side equals x plus 12, but that doesn't matter. This is just like I don't know if saying a bridge is the right thing, but we're allowed to completely flip this thing, right? We can say x plus 12 equals 23. Now we could solve it like this. It's not going to change anything. You still minus 12 from both sides, right? But I don't know. Something that I've been doing in math for a long time is we put the variable to the left. So I go down order of operations. I say again, oh man, I can't do this, right? X plus 12. They're not like terms. 23 is just by itself. So I can do the opposite, right? I can minus 12, which will help me solve for x, right? Because now x is by itself. But what I do to one side of the equation, I must do to the other. So 3 minus 2, 1. 2 minus 1, 1, right? And then we could plug everything back in. So 11 plus 12 is equal to 23. Well, 1 plus 2 is 3. 1 plus 1 is 2. So 23 equals 23, right? We did it right. And the last one, finally last but not least, right, is n plus 265 equals 376. So I agree, most of these, if there was a box, you guys could have figured it out. But this one, I don't know if there's a box if you can necessarily figure it out. Maybe some of you, right? 111 it looks like, because 1 plus 5 is 6, 1 plus 6 is 7, 1 plus 2 is 3. But if you can't see it, it's fine, right? We go through PEMDAS, we say, oh, there's no like terms. I gotta do the opposites. The only thing that's here is this plus. So minus 265, right? That'll get n by itself because n plus 0 is n. But what we do to one side of the equation, we must do to the other. That is the mantra. 6 minus 5, 1. 7 minus 6, 1. 3 minus 2, 1. Now, let's just say we had something like, now I'm going to put myself on the spot. Let's say 9x. So we had 9x minus 7 in the evaluating expressions, right? But let me see if I could find a value for this. I'm trying to think of what we got last time. Well, let's see. Yeah, that'll work. That'll work. Let's say equals 20. All right. So now this one, this is a so-called two-step problem, right? Well, I guess not so-called, it is. But reality is if you're just using a clear head with PEMDAS, right? We'd be able to do this. So now I have a times and a subtraction, right? I go ahead and look at my equation here, my expression, sorry, in my equation, right? I can't subtract these, right? I can't combine them. They're not like terms, right? This would need an x in order for it to subtract. 20 is bland, so I start going top down. Bottom up, sorry, bottom up. So subtractions first before multiply because I'm going upward now, right? So I can add 7 to both sides. 9x plus 0 is this going to be 9x, right? Equals 27. So now what I would do, right? I keep moving up. Oh, I see a multiplication. So I say, what's the opposite of multiplication? Division, right? So this one was a subtraction, but the opposite of subtraction is adding, right? So it's a little bit different than these ones. But, I wanted to just show you guys that this method I have here can really work. And as I upload more videos, I think it'll become clearer because we'll have some very fun problems to work on. So since I have 9 times x, the opposite of timesing is dividing, right? So 9 over 9 will get rid of it, right? 9 over 9 cancels. It becomes x on this side. And how many 9s fit into 27, right? So that's 3. So x equals 3. And now we could always substitute to double check ourselves, right? So we have 9 times 3. Let me maybe box this in so we can not get too confused here with all the problems. Minus 7 equals 20. Well, this one we're going to use PEMDAS to do it, right? So we have a times before we have a subtraction. So this one we're going to get 27 minus 7, which is 20, right? And 20 equals 20. So this value of x that we found, x equals 3, is correct. So that's it in a nutshell, guys. I hope this video was helpful. Please like and subscribe for more videos to let me know that I'm adding some value to your life. Greatly appreciated to just be of service. Comment down below if you're having trouble with any other types of math, quadratics, linear equations, etc. Other than that, I will catch you guys in the next video. You guys have a great day.